introduction to the topic, which is Laplace Transform. Now if we have a signal f of t, the function that is a time domain signal, we can convert it to an s domain signal by taking the Laplace transform of it, and Laplace transform for a signal f of t is defined as integration minus infinity to infinity f of t e raised to the power minus st dt, and this is how the Laplace transform of f of t is denoted, which is denoted by f in brackets s. Now here this s is actually a complex variable which is given as sigma plus j omega, where sigma is the real part and omega is the imaginary part. This Laplace transform is actually same as Fourier transform when it is taken for a signal which is f of t multiplied with e raised to the power minus sigma t, because Fourier transform f of omega for a signal ft is given in this form, where it is integration minus infinity to infinity ft e raised to the power minus j omega t dt. Now if at the place of ft I substitute it as ft e raised to the power minus sigma t and then take its Fourier transform, then it will be something that will be then called as Laplace transform. So we have this as our function and I am multiplying it with this variable e raised to the power minus j omega t, which is then forming our Laplace transform f of s. Now this f of s is actually mathematically same as the Fourier transform, where it is taken out for a value of sigma which is equal to 0. So mathematically, when we find out the Laplace transform considering sigma to be 0, it will then give us the Fourier transform. Now the next part is, depending upon the way the function f of t is, f of t multiplied with e raised to the power minus sigma t should be absolutely integrable, or it should converge to a finite value for the existence of Laplace transform of f of t. This would happen only for particular values of the sigma function, and for the values of the sigma function or the region of the sigma function for which this is happening, that region of the sigma function is then called as the region of convergence, or ROC, for the Laplace transform of a function to exist. Now this ROC is actually defined in terms of sigma or the real part of s, because s is sigma plus j omega, where the real part is sigma. Thank you for watching the video. In the next video, we'll be seeing some example of Laplace transform. Thank you.